Hey, hello, welcome back to channel. In this video we're going to see about evaporation. So evaporation, not as a superficial one. Okay, we are going to go in depth at molecular level how this evaporation is taking place. So that is what we're going to see in this video. So let's begin. So first, the definition. So it is a process by which liquid turns into a gas as a result of increased energy in its particles. Okay, so generally we know that evaporation is a kind of vaporization process where liquid is getting converted to gas. Okay, so now let us go in depth and we'll try to understand what happens to the molecules. Okay, so we are going to take example as H2O molecules. So you imagine that these are H2O molecules present in a beaker and how it is going to get evaporated. So all these are H2O molecules. Okay, this is just for our understanding. I have given some H2O molecules in a beaker. Okay, and up to here it is present. This is the mark where the water has been filled. Okay, now what happens to these water molecules during this vaporization process? Okay, we know that all the water molecules will vibrate, right? Because they are in liquid state and they will be vibrating, and as well as they will be moving from one place to another place, right? Because in liquids generally the particles will be very free and they are loosely packed and they'll be moving from one place to another place, and the energy also will be more. Okay, so this is the first thing we know, that we know the nature of liquids, right? Now the first one is it is a slow vaporization process. Okay, so this doesn't take place very fast, it takes time, and very slowly this evaporation will take place. So as I told, slow vaporization. What does mean by vaporization? Liquid to gas, conversion of liquid to gas. And the second one is it is a physical change. Okay, so what is a physical change? If there is a change in the physical property of a particular object, we are calling it as physical change. Okay, so now in this case liquid water is getting converted to water vapor. Okay, so what is happening here? The state of the matter is alone getting changed. Okay, the state of the matter is alone getting changed, not the chemical composition. In liquid also it is H2O, and if it has converted to water vapor, here also it is H2O. Okay, so in water it is H2O, and in water vapor also it is H2O. So only the state of the matter has been changed. Okay, so that is why it is called as physical change. Okay, so this is the second point. And the third one is occurs at any temperature. So in case of evaporation, it's not that it will happen at one particular temperature. It can occur at any temperature. You just imagine that you take a small cup of water and you're keeping in a corner of your room or somewhere else. If you're checking the level of the water after 2 or 3 days, what happens? The level of the water decreases, and you are not going to provide any external energy during that time. Okay, you are not going to heat or you're not going to do something. You're just keeping it and you're not going to disturb the cup of water. Okay, so it occurs at any temperature. Now this is a surface phenomenon. Okay, so now let us try to understand why it is evaporation is called as surface phenomenon. Okay, so now this is the surface water molecules. Okay, 1 2 3. Okay, these are the surface water molecules. Okay, now what happens to these surface water molecules? And the reason we are calling it a surface phenomenon is that only the surface water molecules will be converting to water vapor. Okay, only the surface molecules will be getting converted to water vapor. Why only the surface molecules are getting converted to water vapor? What happens to the molecules which are present at the bottom? Nothing is going to happen. Okay, so the first surface, that means the first level of water will get converted. Maybe if you're leaving the water for some more time, the next level of water, so only the surface molecules are getting converted to water vapor. And the nature of the surface water molecules is somewhat very free. That means the energy is more. Okay, the energy is maximum in the surface water molecules when you are comparing with the water molecules which are present at the bottom. Why? Because the intermolecular force of attraction is less in case of surface molecules when you are comparing with the molecules present at the bottom, because of which the energy also will be maximum and it can easily convert to water vapor. Now, how it is going to convert to water vapor? It is because of the energy from the surroundings. Okay, so the surface water molecules are going to gain the energy, or going to absorb the energy from the surroundings. Okay, so from the atmosphere, the surface water molecules will be gaining the energy. Okay, so initially slowly it will be gaining the energy from the atmosphere and it starts getting converted to water vapor. Okay, as you can see, the surface water molecules have been converted to water vapor. Okay, so this process is called as evaporation, where the surface water molecules gains energy from the surroundings and slowly, as you know, like already I told, the surface molecules will be having the maximum energy. Already it is trying to escape from the water state to the water vapor state, from liquid to gas. So as it is gaining energy from the surroundings, what happens? It gains some more energy and it is starting converted to water vapor. Okay, so now the first level of water has been converted to water vapor. Now this will be considered as the surface water molecules. So again, if you are leaving it for some more time, what will happen? It gains energy from the surroundings. Again, all the water molecules present at the surface will gain energy from the surroundings and it starts vibrating very fast, and the movement also will be very fast, such that it is again getting converted to water vapor. So to like when these processes are happening, this process will not take place very fast. So that's why I mentioned it as it is a slow vaporization process. Okay, so this is all about evaporation at molecular level. What exactly is happening to the molecules when it is getting evaporated? Okay, I hope you are clear with this concept. So thank you all. Happy learning.